Hello students, uh, welcome back to the video. Now as I promised earlier, now we're going to solve. I'm going to teach you how to solve the rest of the problems in this video, which I have titled Trigonometric Equations Part 2. So let us start solving. Let me take let's say x be an angle between 0 degrees and 360 degrees. Okay, so let's say for example, if I have to solve sine 2x equal to minus half. Okay, now we all know that sine 30 degrees is half, so let us write 30 degrees. And what are the angles? Other angles 150, 210 and 330 degrees. So you might write, you consider this 2x as x. Okay, so that means 2x can be either minus 210, isn't it, and minus 300 I'm sorry, not minus, 2x can be either 210 or it can be, let me erase it, it can be either 210 degrees or 330 degrees, right? Because sine is negative in the third and fourth quadrant, so that's why we have chosen these two angles, 210 and 330 degrees. So you might feel, okay, fine, that's all, the problem is over. Not so. There are actually two more solutions. How do we find that? Now it is given here that x lies between 0 degree and 360 degree. But what you see here is not x but actually 2x. That means 2x can take any value between 0 degree and 720 degree. So which basically means 0 degree to 720 degrees means two full rotations, isn't it? That means first quadrant, second, third and fourth, and again first, second, third and fourth. That means we can have two more answers. So how do you get the third one? Very simple, add 360 with 210, which is nothing but 570 degrees. Okay, and we can also add 330 with 360, so I'll get 690 degrees. So 2x can be either 210, 330, 570 or 690, but my objective is to find the value of x. So x is nothing but 210 divided by 2, which is 105 degrees, 330 degrees divided by 2, which is nothing but 165 degrees, 570 degree divided by 2, which is nothing but 285 degrees, and finally 690, it's nothing but 345 degrees. So these are the four solutions for this particular trigonometric equation, right? Okay, now let us consider another problem. Let's say cos of x upon 2 is equal to let's say root 3 by 2. Okay, so we know that root 3 by 2, we know cos 30 degrees is equal to root 3 by 2. So let me write all the four angles: 130 degree, 150 degree, 210 degree and 330 degrees. So you may feel that, okay, fine, it's positive root 3 by 2, so obviously x can take any value in the first and the fourth quadrant. So you may write that x by 2 equal to 30 degree and 330 degrees, because the first quadrant and the fourth quadrant. But this is incorrect. You may remember that in the previous problem we got four solutions, and in this one you got two solutions, and I'm saying that it is wrong, it is incorrect. So you may wonder, oh, does it mean that we have two more solutions, sir? No. In fact, this particular trigonometric equation has only one solution. And you may ask, like, how is that, sir? Let us see. If x lies between 0 and 360 degree, then obviously we have x by 2 here, isn't it? So x by 2 lies between 0 degree and 180 degrees. That means x by 2 lies in the first or the second quadrant. So you can't take 330. This is incorrect. So you can take only 30 degrees. So if x by 2 is 30 degree, x is 60 degree. So that is the solution for this particular trigonometric equation. So I hope it is clear to you, students. Let us see one more example. Okay. Let us look at this. Tan 2x by 3 equal to, let's say, minus root 3. Okay. Now we all know that tan 60 degrees is root 3. So let me write all the four angles: 60, 120, 240 degrees and 300 degrees. Now since here tan value is negative, it has to be in the second quadrant and the fourth quadrant, isn't it, students? So you write 2x by 3 can be either 120 degrees or it can be 300 degrees. Now again you want to check whether both 120 degrees and 300 degrees are the solutions, or only one of them is a solution, or like we did like the first problem, are there more than two solutions for this? Let me check. How do you do that? Very simple. X lies between 0 degree and 360 degree. Yeah. So it means 2x lies between 0 degree and 720 degree, isn't it? Multiply throughout by 2. But I have 2x by 3 here. So 2x by 3 lies between 0 degree and 240 degrees. So that means I cannot take this 300 because 300 is above 240. So it means 2x by 3 is equal to 120 degrees. So x is 120 degree multiplied by 3 by 2, so which is nothing but 180 degrees, right? So for this particular trigonometric equation, there is actually only one solution. So I hope this is clear to you, students. Okay, fine. So let us see now x. For the following problems, I'm going to take x between 0 and 2 pi. Okay, so which is nothing but 360 degree. 2 pi is nothing but 2 pi radian is nothing but 360 degree. Okay, first sum. Let's say sine x equal to cos x. How do you solve this? Very simple. I can write this as sine x divided by cos x, equal to 1, isn't it, students? Okay, and I've seen students writing it as 0. Sine x by cos x equal to 0. That is incorrect. Sine x by cos x equal to 1. So basically you, by bringing cos x to the denominator of sine x. Okay, so which is nothing but tan x equal to 1. Now we know that tan 45 is 1, so x has to be 45 degree. One answer is 45 degree. And we also know that tan is positive in the third quadrant also. So third quadrant is 180 plus 45, so which is 225 degrees. But here I have given the interval as between 0 and 2 pi. So which means it is better that you write the answer in radian. Now we know that 45 degrees is nothing but pi by 4 radian, and 225 is nothing but 5 times 45 degrees, isn't it? So 225 is nothing but 5 pi by 4. So the solutions for this trigonometric equation, that is sin x equal to cos x, is pi by 4 and 5 pi by 4. Okay, so let us look at another problem. So this is the next problem, students. 10 sine squared x equal to 5. So I can write it as sine squared x equal to 5 upon 10, which is nothing but 1 upon 2. So it means sine x can be either plus or minus square root of 1 upon 2, which is nothing but plus or minus 1 upon root 2. It means sine x can take the value of 1 upon root 2, or sine x can take the value of minus 1 upon root 2. Okay, if sine x is 1 upon root 2, I know that x can be 45 degree or second quadrant, which is 135 degrees. If sin x is minus 1 upon root 2, then x can be third and fourth quadrant, isn't it? So 225 degrees and 315 degrees. So basically there are four answers. Now if I write it in radian, it will be pi by 4, and this will be 3 pi by 4, 3 times 45. This will be 5 pi by 4, and 315 is 7 times 45, so 7 pi by 4 is the answer. So I hope this problem is clear to you. So let us look at another problem. Okay, let us look at this problem, students. Sine squared x by 2 is equal to 3 cos squared x by 2. So what I'll do is, I'll write it as sine squared x by 2 upon cos squared x by 2 equal to 3. Right? I'll bring this cos squared to the denominator of sine squared x by 2, which is nothing but tan squared x by 2 equal to 3. Right? Isn't it? Sine by cos is tan. So if tan squared x by 2 is 3, it means tan x by 2 is nothing but plus or minus root 3. So it means tan x by 2 can be either plus root 3 or tan x by 2 can be minus root 3. Okay, so this means x by 2 can be equal to, so when we will get root 3, 60 degrees and also 240 degrees, isn't it, students? Because tan is positive in the first and third quadrant, and the third quadrant we get 180 plus 60 is 240, and here x by 2 can be equal to, I mean tan is negative here, so second and fourth quadrant, so 120 degrees and 300 degrees. Now you may feel that this is the answer, that there are four solutions for this, which is not correct, students. Okay, you missed a simple thing here. The important thing is x by 2. So whenever you have this 2x or 3x or x by 2 or x by 3, you have to be very, very careful. Now it is given that, let me use, please look at the top right hand corner. Okay, it is given that x lies between 0 and 0 and, let me erase this, x lies between 0 and 2 pi, which means x upon 2 lies between 0 and pi. That means you can take only till 180 degrees. So you can't take this and you can't take this. These two are not possible. So obviously x is equal to 120 degrees or x equal to 240 degrees. So this particular trigonometric equation has two solutions. Fine. Let us look at another problem. Okay. Now look at this problem. Sine 2x equal to cos x. Okay. Now we know that sine 2x can be written as 2 sine x cos x equal to cos x. Now I have seen, after this, I have seen many students commit this mistake. They write 2 sine x cos x divided by cos x equal to 1. They write like this. That means they bring the cos x to the denominator, and then they cancel cos x and cos x, and they write 2 sine x equal to 1. Okay, this is incorrect. Now you might wonder what is wrong in this, sir. I mean, cos x are same. It's like cancelling 3 and 3 or 4 and 4. Why can't I cancel cos x and cos x? Okay, let me give you a very simple example. 0 into 3 equal to 0 into 5. Isn't it, students? Both of them are same. 0 into 3 is 0. 0 into 5 is 0. So can you say that, okay, I'll bring this 0 down here. So I'll write it as 0 into 3 by 0 equal to 5. Then I'll cancel 0 and 0, which means 3 equal to 5. Now, don't you think this is wrong, students? That how can 3 be equal to 5? Now, you got this error because you cancel 0 and 0. Same way, cos x can take the value of 0, isn't it? We know that cos 90 degrees is 0 and cos 270 degree is equal to 0. So, cos can become 0. So this step, actually this step is incorrect. You cannot cancel it. Yeah. So you might wonder, then how do we do it, sir? If we can't cancel cos x, because cos x can take the value of 0, so how do we solve this then? This is how you do it. Okay. What you do is you bring cos x to the left hand side. You write 2 sin x cos x minus cos x equal to 0. Then you factorize, you take cos x common. So cos x into 2 sin x minus 1 equal to 0, which means, like the cos x equal to 0 according to the zero product rule. Either cos x is 0 or 2 sin x minus 1 equal to 0, which means sin x equal to half, right? So cos x equal to 0 means x can take the value of 90 degrees or it can take the value of 270 degrees. So here sin x equal to half means x can take the value of 30 degrees or it can also take 150 degrees. So if you want to write it in radian, it is nothing but 90 degrees is pi by 2, 270 degrees is 3 pi by 2, 30 degrees is pi by 6, and 150 degree is 5 times 30, so 5 pi by 6. So this particular trigonometric equation, that is sin 2x equal to cos x, has 4 solutions, students, right? Okay, let us look at another problem. Okay, let us look at this problem. Tan x equal to sin x. Okay, how do we solve this? Very simple. I write tan x as sin x upon cos x equal to sin x. Then I cross multiply. I write it as sin x equal to sin x into cos x. Okay. Now please do not cancel sin x and sin x. As I told you earlier, sin x can take the value of 0. So you don't cancel sin x. So what you do is you bring it to the left hand side. You bring the sin x cos x to the left hand side. So sin x minus sin x cos x equal to 0. So take sin x common. You get 1 minus cos x equal to 0. So that means either sin x is 0 or 1 minus cos x is 0, which means cos x is equal to 1. So this means x can take the value of 0 degree or 360 degree. Here x can take the value of 90 degrees. That's all. And also, sorry, 360 degrees. Okay, so it means x can be pi or 2 pi. Here pi by 2 or 2 pi. So the final answer is, I'm really sorry, this is not pi, this is 0. So 0 radian. So 0. So the final answer is 0, 2 pi or pi by 2. So this particular trigonometric equation has 3 solutions. Okay. Now let us look at another type. 2 cos squared x equal to sine 2x. Okay, I can write it as 2 cos squared x equal to sine 2x is nothing but 2 sin x cos x, isn't it? Now again, please don't cancel cos x. Bring 2 sin x cos x to the left hand side. So you get 2 cos squared x minus 2 sin x cos x is equal to 0. So take 2 cos x common. You get 2 cos x multiplied with cos x minus sin x, so equal to 0. It means either 2 cos x is 0 or cos x minus sin x equal to 0. Now this means cos x equal to sin x. Now again I can write this as sin x upon cos x is equal to 1, which means tan x equal to 1. Okay, if 2 cos x is 0, that means x can take the value of 90 degrees and 270 degree. Here x can take the value of pi by 4, basically 45 degrees and 225 degrees. That means if you write it in radian, it will be pi by 2, 3 pi by 2, it will be pi by 4 and 5 pi by 4. Okay, very simple. Okay, now let us look at this trigonometric equation, students. 3 sin squared x minus 11 sin x plus 6 equal to 0. As you can see, this is a quadratic equation in terms of sin x. So what I'll do is I'll take sin x as some other variable. Let's say sin x as a capital small a. Then this will become 3a squared minus 11a plus 6 equal to 0. Now let me try to split the middle term. So the product, I have to find two numbers whose product is 3 times 6, which is 18, and whose sum is minus 11. Okay, I know that those two numbers are nothing but minus 9 and minus 2, isn't it? Minus 9 times minus 2 will give you plus 18, and when you add them you'll get minus 11. So I can write this as 3a squared minus 9a minus 2a plus 6 equal to 0. That means I am writing minus 11a as minus 9a minus 2a. Now from the first two terms, let me take 3a common. So 3a multiplied with a minus 3, and from these two let me take minus 2 common into a minus 3 equal to 0. Now which means a minus 3 into 3a minus 2 equal to 0. Okay, now according to the 0 product rule, so a minus 3 is 0, or 3a minus 2 is 0, which means a equal to 3 or a equal to 2 upon 3. Now we all know that a is nothing but sin x, so sin x is equal to 3 or sin x equal to 2 by 3. Now we know that this is not possible, isn't it, students? Do you know why it is not possible? Okay, we all know that the value of sin x, the maximum value of sin x is only plus 1, and the value of sin x lies between minus 1 and plus 1. So definitely sin x equal to 3 is not possible. Okay, I mean here let me write it in the top right hand corner. Sin x, the maximum value is plus 1 and the minimum value is minus 1. So it lies in that interval. So there is no way sin x can give you 3 as the answer. Now how do we solve this? Sin x equal to 2 by 3. So obviously you have to use the calculator. So let me use the calculator. So in the calculator you find sine inverse of 2 by 3. So sine inverse of 2 by 3, which will be equal to, okay, so you will get 41.8 degree as one answer. Now please make sure that okay, if you want the answers in degree, the input mode in the go to run mode, and then the input is in degrees. Okay, now we all know that sin x equal to 2 by 3, so 2 by 3 is positive, which means x can be an angle in the first quadrant or the second quadrant. So this is the first quadrant angle. So to find the second quadrant angle, very simple, you subtract 41.8 from 180. So 180 minus 41.8, so that will give you 38.2 degrees. So these are the two solutions for this particular trigonometric equation. Now what happens in case, let's say for example, the input mode is in radian, then what you need to do is, so in case if the input is in radian, then when you find sine inverse of 2 by 3, you will get 0.730 as the answer. Correct to three significant figures. Then the other angle is, please don't subtract this from 180 degrees. Now you have to subtract it from pi. So the other angle is pi minus 0.730. So you can use the calculator. Don't use pi as 3.14. There is a button with pi sign. I think it is above exp, the exponent. Expression. So you can use shift exp. That will give you pi, and so this will give me 2.41 as the answer. So this is one answer, 0.730, and the other answer is 2.41. So this is if it is in terms of radian, and 41.8 degrees and 138.2 degrees, it is in terms of degrees. Okay. Now please look at this particular trigonometric equation, students. Cos 2x equal to sin x. Now we all know that there are three, I can represent cos 2x in three ways. I can write it as cos squared x, minus sin squared x. I can also write it as 2 cos squared x minus 1, and I can also write it as 1 minus 2 sin squared x. So which one are you going to use for cos 2x here? Very simple, you need to use the third one because right hand side is sin x. So I'll write it as 1 minus 2 sin squared x equal to sin x. So I will rearrange the term. So you'll get 2 sin squared x plus sin x minus 1 equal to 0. Now you can see you get a quadratic equation in sin x. So what I'll do is I'll let sin x equal to a. So you'll get 2a squared plus a minus 1 equal to 0. Now if I split the middle term, I'll get 2a squared plus 2a minus a minus 1 equal to 0. So let me take 2a common from the first two terms, I'll get a plus 1. Let me take minus 1 common from the last two terms, I'll get a plus 1 again equal to 0. So which means 2a minus 1 into a plus 1 equal to 0. So this will give me either a is half or a is minus 1. But we know that a is nothing but sin x. So sin x is either half or sin x is equal to minus 1. Now we know that if sin x is half, then x will be either 30 degrees or 150 degrees. If sin x equal to minus 1, then x is 270 degrees. Yeah, this is the answer. Very, very simple. I hope this is clear, students. Now what if you have cos 2x equal to, let's say, cos x? Then how do you solve this? Now what you need to do is, instead of cos 2x, you'll use this formula, 2 cos squared x minus 1. So 2 cos squared x minus 1 equal to cos x. That means 2 cos squared x minus cos x minus 1 equal to 0. Then here you get a quadratic equation in cos x. So let cos x is equal to a. That means you'll get 2a squared minus a minus 1 equal to 0. Then again you can split the middle term and solve this problem. I hope this is clear. Okay, okay, fine, let me just complete it. I get 2a squared minus 2a plus a minus 1 equal to 0. That means take 2a common, a minus 1 plus 1 into a minus 1 equal to 0. So you get 2a plus 1 into a minus 1 equal to 0, which means either a is minus half or a is equal to 1, which means either cos x is minus half or cos x equal to 1. So this will give me x is either 120 degrees or 240 degrees. This means x is either 0 degrees or 360 degrees. Very, very simple. Okay. Now how do we solve this, students? Sin x minus 1 equal to cos squared x. Now we know that cos squared x is equal to 1 minus sin squared x, right? So I can write it as sin x minus 1 equal to 1 minus sin squared x. Now if I rearrange it, I'll get sin squared x plus sin x minus 2 equal to 0. Now as you can see, this is a quadratic equation in sin x, and if you take sin x as a, you will get a squared plus a minus 2 equal to 0, and then we can go ahead and solve it like we did in the previous two problems. So it's very, very simple. So let us see one more problem. Okay, look at this problem, students. 2 sin squared x equal to 1 plus cos x. Now what you need to do is you have to look at, can you get a quadratic equation in either sin x or cos x? So that should be an objective. So here we know that sin squared x can be written as 1 minus cos squared x. So I'll write it as 2 times 1 minus cos squared x equal to 1 plus cos x. So simplify, open the bracket, 2 minus 2 cos squared x equal to 1 plus cos x. So you get 2 cos squared x plus cos x minus 1 equal to 0. As you can see, you get a quadratic equation in cos x, so you can take cos x as a, so you will get 2a squared plus a minus 1 equal to 0. Then you can split the middle terms. Then if it is a non-calculator paper, if it is a calculator paper, you can use the calculator to find the answer. Yeah, very, very simple. Look at this problem, students. Cos squared x equal to cos 2x. Again, very, very simple. I will write cos 2x as 2 cos squared x minus 1. So if you simplify, you'll get cos squared x as plus 1, which is nothing but cos x is plus or minus 1. So either cos x is plus 1 or cos x is minus 1. So if cos x is plus 1, then x can take the value of 0 degrees and 360 degrees. If cos x is minus 1, then x can take the value of 180 degrees. Very, very simple. Okay. Now how do we solve this now? 4 minus cos 2x plus 5 sin x equal to 0. What I'll do is I will substitute cos x as 1 minus 2 sin square x for the simple reason that you have 5 sin x here. So 5 sin x, because you have 5 sin x. So in case if we have 5 cos x here, then you will write cos 2x as 2 cos square x minus 1. So it is 4 minus 1 plus 2 sin square x plus 5 sin x equal to 0. So if you simplify, you will get 2 sin square x plus 5 sin x plus 3 equal to 0. So quadratic equation in sin x, you can take sin x as a, and you can solve this problem. Yeah. Okay. Look at this problem, students. Cos 2x minus 3 cos x minus 3 minus cos squared x equal to sin square x. So you have cos x here, you have cos 2x here, you have cos squared x, you have sin square x. So how can I make it into a single function? Now what you do is you make it into cos x, because you have 3 cos x here, so make everything into cos x. So cos 2x is 2 cos square x minus 1, so this is 2 cos square x minus 1 minus 3 cos x minus 3 minus cos square x, and sin square x is 1 minus cos square x. Yeah, of course you can take this minus cos square x there and it will become 1, sin square x plus cos square x. So I can cancel this and this. So I'll get 2 cos squared x minus 3 cos x and minus 5 equal to 0. Okay, so you get a quadratic equation in cos x. You can go ahead and solve this. Okay, so I think we've seen quite a number of problems where the equation gets converted into a quadratic equation in either sin x or cos x. So that is how you do the sums rules. So finally, I'm going to give you some problem based on calculator. Okay, how do we find the solutions using calculator? Let us see it. Let us look at this problem. Cos x equal to 3 upon 5. So definitely we know that x is an angle in the first quadrant and the fourth quadrant, because cos is positive in the first and fourth quadrant. So find cos inverse of 3 by 5, and in case if it is in degree mode, you will get this answer. You will get 53.1 degrees. That means x can be either 53.1 or it can be 360 minus 53.1. So basically x can be either 53.1 degree or 306.9 degree. Yeah, so this is a solution. In case when you find cos inverse 3 by 5 and your input mode is in radian, then you will get this answer, students. You'll get 0.927. So that means x can be either 0.927 or fourth quadrant, that means 2 pi minus 0.927. So if you use the calculator, you'll get this answer. You'll get the same answer here, and 2 pi minus 0.927 is 5.36 radians. Okay, so this is how we do it. Okay, now how do you do this problem? Sine x equal to minus 3 by 4. Now I've seen many students find sine inverse of minus 3 upon 4. Please don't use that method. What you need to do is find sine inverse of 3 by 4, not minus 3 by 4. Find sine inverse of 3 by 4. You'll get 48.6 degree as the answer, right? Now, since sine x is minus 3 by 4, x has to be an angle in the third and fourth quadrant. So that means x has to be 180 degree plus 48.6 or 360 degree minus 48.6. That means the answer is either 228.6 degree or 311.4 degrees. Okay, two more problems, and with that this we will stop. I'll stop after that. So cos x equal to minus 1 by 3. So as I told you earlier, find cos inverse of 1 by 3, not minus 1 by 3. Find cos inverse of 1 by 3. You'll get 70.5 degrees as the answer. So, but here cos x is minus 1 by 3 means x has to be an angle in the second quadrant or the third quadrant. So x is either 180 degree minus 70.5 or 180 degree plus 70.5. So that means it is either 109.5 degrees or 250.5 degrees. Okay, so very, very simple. Okay, last problem for this video. In this video, tan x equal to minus half. Okay, so as I mentioned earlier, find tan inverse of half. Tan inverse of half, which is nothing but you get 26.6 degree as the answer. Now since tan x is negative, it has to be an angle in the second and the fourth quadrant. So x is either 180 minus 26.6 or it has to be 360 minus 26.6 degrees. That means it is either 153.4 degrees or 333.4 degrees, right? Okay, so that's all, students, for trigonometric equations. So I hope you've watched both the videos, and I hope this has sort of these videos have helped you understand the concept better. Now I suggest that you solve more problems. Or maybe if you want, you can watch these videos quite a few times, a few more times, and solve as many sums as you can. But definitely there's no substitute for practice. As far as math is concerned, you have to practice a lot, and that will help you improve your performance. Yeah. So thanks for watching these videos, students. See you then. Bye.